Hello and welcome to the Weekly Space Hangout for Wednesday, June 6, 2019. I'm Fraser Kane, publisher of Universe Today. This week we're going to be talking about NASA has ordered a bunch of moonlanders, an update on InSight's digging problem, seeing moon-forming disks from afar, James Webb comes out of the vacuum, Curiosity finds the mother lode of clay on Mars, and a cool gas ring around Sagittarius A star. Joining me this week, I've got on my screen, friend of the show, Dr. Brian Koberlein. Dr. Koberlein,
Hi,
welcome
everybody.
back.
Thank you.
As much as I appreciate the fact that you are a professor, I also appreciate that when you don't have to be a professor, you get to join us.
That's right.
So thank you. We really appreciate having you here, especially because our resident, our tamed astrophysicist is so busy right now.
Out of the cage.
Yeah, out of the cage. How did that happen? All right. I've also got Dr. Morgan Renberg. Morgan.
Hey, everybody. I can't believe it's already June.
I know. We are like 2 more episodes after this, and then we wrap up the season. So, and then I'll really start to work on my tan. You get to see this. You can see.
It's just good old Vancouver sunbathing days.
I know. Yeah, they say I live in a coastal rainforest, but yeah, I've been out in the sun quite a bit. We've got Dr. Kimberly Cartier. Kimberly.
Hey, Fraser, happy podcast day.
Yay, she said the words.
Yeah, of course I said the words. What do you think I'm going to say?
I don't know. At some point
of course
you're going to forget.
I said them.
Then we're all going to freak out. It's going to feel like there's like some...
No, there was one week where I didn't say them, and you were like, wait, what? Are you done? And then Morgan had to say them, and everyone was confused. So
That's awesome.
It's just best if you let me do my job.
All right. Well, before we get into our special guest, we are going to just take a moment here and make a deep thank you to our good friends at the Weekly Space Hangout crew. This is our community. These are our executive producers. These are our bosses. These are the people who help keep the show running, and we couldn't do it without them. So if you want to be a part of this amazing community, go to wshcrew.space. They will hook you up to the chat that's going on during the show. They will give you your own access to business cards so that you can be an executive producer of the show and bring on amazing guests like we're going to have today. All right. And speaking of, let's get on with the guest. Jean Wright, welcome to the Weekly Space Hangout.
Welcome. Thanks for having me.
Awesome. First, thank you so much for jumping through all of the technical hoops that it took to get you here. It almost felt like we were putting a person on the moon. That's how hard it was, or at least in space. But we did it.
I was thinking more like Apollo 13.
Yeah, exactly. So who are you, and what do you do?
Well, right now I'm retired from NASA, but I'm a docent, which is Latin for teacher. So I do launch support. I did tours at Atlantis, talk about what I did. Technically, when I was working for NASA, I was the seamstress on the Space Shuttle, and we were called Aerospace Composite Tech Soft Goods. Soft goods is NASA speak for anything to do with fabric. So there's a lot of hand sewing on shuttle. And when I tell people that, the first thing they say is, oh, you must mean the spacesuits. And I go, no, we did flight hardware. There's a lot of flight hardware that's done by hand on the shuttle.
Okay, well, I'm sure when you bring that up, everyone's next question is, what? Explain.
Yes, what?
Yeah, where is all the sewing required on a space shuttle?
Well, let me tell you this. Our number one question when people come into the Atlantis exhibit is they say, is this the real one? Because it looks fake. And when I ask them why it looks fake, they say, well, because her skin looks like it's paper mache. And I smile because I know exactly what they're looking at. We have over 2,200 fabric blankets on the outer skin of the shuttle that are quilted on a giant 30-needle sewing machine, but every one of them have to be hand-knotted and stitched by hand before they're glued on. So then we bake the blankets at 650 for 4 hours, bump it up to 850 for 2 more, and heat clean the blankets till they shine literally like silk. Then they get glued on with RTV or room temperature vulcanization glue, get a clear coat of ceramic paint, then 4 hours later a white coat. And so we have different shades of white, so it does kind of look like paper mache. So that's why they think it's fake. But really, and we do that. We do the thermal barriers around the wheel well doors to make sure the doors shut tightly. gap fillers between the tile, not only for thermal protection, but to pad the sidewalls of the tile. We do all the payload bay blankets. There's about 1,200 of those. 5,400 silver polyimide blankets that protect the astronauts from radiation. Those are done by machine. And then we have huge blankets that we put around the engines called dome heat shield blankets, and those are actually quilted on an antique sewing machine named Lurch, because we have a tradition in NASA from the mid-60s. All of our sewing machines get a name. He happens to be our oldest one, being built in 1914. He's the Singer 9710, and his first job was sewing saddles. So we're sewing through really thick Serichrome when we're making the blankets around the engines. But those are done by machine and by hand, and they take us 4.5 days just to do one half of the two blankets. But what really amazes people is how we install them, because we actually have a wire called Inconel 625 that we hand sew them onto the back of the shuttle for flight. So that surprises everybody.
So how did you get the gig of being the person who handles the sewing for NASA?
Well, I knew there was some sewing involved with the spacesuits, but then as we have returned to flight, they do a lot of articles, since I live here in Florida, about the Space Shuttle, and they actually had a picture of a woman sewing a blanket. Her name was Pilar, and sight unseen, I sent her an email asking what the qualifications were, but I applied. You just apply with the skills, and I knew how to read basic blueprints, which was key, because we actually make our own patterns to make our shuttle parts. So I applied, and I didn't hear anything for 6 months, did a lot of praying, literally, studied the computer. Literally, I knew thermal protection was the system I wanted to work on, because it's the most important one for shuttle. And I literally got on the computer and studied at least an hour or two every day for almost 6 straight months. I retweaked my resume. 4 days later, I got a call on caller ID with Kennedy Space Center on it, and I thought somebody was playing a cruel joke on me. And so I had an interview a few days after that. It was a 2-hour-long interview in front of 4 different people. And then after my interview, they asked me if I wanted to go out to the thermal protection facility. But I thought that was the courtesy everybody was given, because they hadn't hired anybody for this position for the last, probably 9 years. I ended up finding out I was the last one hired in the whole program. When my boss called me 4 days later to tell me I got the job, he was a little frustrated, because he said, the fact that we invited you out there, we thought you knew. And I went, no. But he said, you knew so much about the shuttle program. You had such heart and compassion. We were still feeling the loss from losing Columbia. And he said, we needed heart in this building. And I could see that the second you opened up your mouth. It was a bit kind of odd to put. When we were temporarily assigned to the white hangar out at the shuttle landing strip, that's where they reassembled Columbia after we lost her. So we still had the white tape outline on the floor, and every day we would go to work, we'd have to step over that white line.
I remember seeing a picture of that, where they had all the parts in the shuttle. Yeah. That's just heartbreaking.
That was sad. It's a reminder. It's a good reminder that you need to be very, very good at what you do.
Well, and that was my question was like, what kinds of standards? Where did you need to be really careful with the work that you were doing? What were the sort of the tolerances to make it all come together?
Well, you're right about tolerances. I have to say, all of it was important, but especially we had different specifications when we were sewing parts for the crew compartment. Things are just entirely different there. The adhesives that we would use, RTV that we would use around the window, there's a phenomenon called outgassing where it streaks. So you don't want streaks on your windows. So we had a special, very expensive white RTV that would be used around the windows. It was just things like that. The tolerances were most of them for stitches. It was plus or minus 12 stitches per inch by hand, plus or minus a stitch. 4 stitches when we used our giant sewing machine that quilted the blankets on the outside. But I would have to say the most sticky tolerances were probably when we were working inside the wheel wells, because those thermal barriers that we make are 4 feet long. They take us 4 days a piece to do by hand. and we have a high temperature thread that melts at 3,250 degrees. It's called AB440, and it's a bright neon pink. So that thread would be used in the wheel wells, inside the nose, leading edge of the wing, and even in the elevons or the wing flaps. But those thermal barriers are so important, especially in the nose landing gear, because people think it's the bottom of the shuttle or the black tile that gets the hottest on reentry, but that's absolutely incorrect. It's where you see, it's considered a fabric. It's called reinforced carbon-carbon because it starts off with graphite rayon fabric, and through many steps, the fabric gets as hard as a rock. So we have 22 panels on the leading edge of the wing. Panels 6, 7, and 8 are the second hottest area on reentry, but the hottest on her, believe it or not, there's a special, what we used to call the shuttle smile. It's on her, it's called the chin panel, and it's right underneath the nose, and we build the nose out of 4 inches of the RCC, and at that thickness, it can withstand 4,000 degrees. So it's really the nose that's the absolute hottest on her. So we would build special blankets inside the nose to fill that cavity because that is the hottest.
I've got a question from Arjone, who's watching the show right now, and they ask, do you know any special stitching patterns, or do you use tried and true normal stitching patterns? So are there any special techniques that you needed to use?
Well, yes, and well, we have, believe it or not, there's a government standard book that has over 400 seams that you can do. And it's the way fabrics are draped and how many times they're folded over. It's things like that. Stitches, pretty much basic. Some of the most visible is on the ohms pod, which is the 2 big humps between the tail. Right where the tiles join to the blankets at the very back, we actually do an overcast stitch, which is an old-fashioned stitch by hand on all the seams to pull the blanket seams together as tight as we can get it to make that area as aerodynamic. But I think the most things that I get asked about is the needles, because everybody thinks we use super fantastic needles, and they're surprised when I tell them that we just go to Joann's or we just go to any fabric store. And there's a reason for that. Some of our gap fillers that we make between our tile, there's a special foil called Inconel, and that's kind of like our interfacing, and it stiffens the gap filler. And they look like little white slivers. We used to call it fabric caulking between the tile. The NASA guys would give us square holes to stitch those by hand, and the square holes would be punching too big a foil, and sometimes you would tear the foil. So we found that if we just went to a regular fabric store and got curved needles that had a curved hole, the needle would slide evenly, and without any, it would make large holes. It would just like it would glide right through. So it's the needles that people ask me. They think we use super heavy duty needles, but we don't.
Right.
We don't.
Space age needles.
No, I wish. No.
So,
That's the one thing I love about it, though, because I always talk, when I do my talks, I talk about how something is thousands and thousands of years old. We still use it on shuttle, anything that JPL makes or unmanned capsule spacecraft, everything needs the insulated blankets, and everything is either done by machine or by hand. So it's 1,000-year-old traditions, but we still need them for all of our modern spacecraft.
So speaking of modern spacecraft, I mean, the age of the shuttle is over, and now we're moving to the Orion capsule and some of the other technologies. Do you know, I mean, you're out of NASA right now, but are you keeping track of what sort of, are these techniques being used? Is this also being applied to some of the new spacecraft?
It is. Every blanket that we're using, we have blankets that we call MLI, for multi-layered insulated blankets. On shuttle, it's just Dacron mesh layered between mylar sheets that are very, very thin. So an 18-inch layered blanket is really only about an eighth of an inch thick, which is very thin. JPL, for their capsules or spacecraft that are going to Mars and beyond, they use a minimum of 32 layers in theirs, and a special film called Carbon Field, and it's a black film that actually is anti-electrical because of static. But as for Orion, I did have a small part of Orion. We used our giant multi-needle sewing machine that sews 30 rows at a time of stitching for the outside blankets on shuttle. We actually made aft skirt blankets. So I did test blankets for Orion, and even worked on the parachutes, the test parachutes for Orion. Now that's a trip, because the top of those parachutes are 8 inches thick, and we had a sewing machine called Thumper, And there was a reason why he was called that, because every stitch sounded like you were hitting the wall. The needle was 9 inches long, and each stitch was like maybe every 2 seconds. That was the only sewing machine I ever worked on that intimidated me.
Right.
But those ribbons at the top, we would pull test to whatever the pound ribbon was. A 20-pound ribbon would be pulled with a 20-pound weight. At the top of the canopy, we had 50,000-pound test ribbons that we would have to pull. Couldn't do that on a table. We actually had a machine in the floor that you would stick the ribbon in, pull it to 50,000-pound test, but there was a cord around it because they told us if one of the ribbons broke, we literally would be cut in half if we stood too close to the ribbon being pulled. So you learn to stay away.
Yeah. So you mentioned there like that some of the newer stuff they need 32 layers. Space Shuttle only stayed within, like in low Earth orbit, within the Earth's protective magnetosphere, but the Orion and other spacecraft are potentially going to be heading out to beyond, outside the larger radiation load, and so you can see a lot more of those layers coming into play. Was that the same kind of thing they were doing during the Apollo era?
Yes, every spacecraft has thermal blankets. Everyone. I haven't seen any old Apollo blankets. They're the same films we use. A lot of the film that we would use, Vice Fabric in our shuttle parts, those are Apollo era. So the polyimide would be Apollo era. Some of the Mylar would be Apollo era. But you're right about our distances. I happened to go to the New Horizons on New Year's Eve, and we're talking beyond Mars to almost the edge of the solar system. So yes, the blankets need to stay. We always say we would check the blankets from heat, but when you go that far, the blankets are to keep those spacecraft warm.
I just can't, like, when you think about how complicated these spacecraft are, how many parts there are, and when you look, now that I'm looking at some of the pictures of the Space Shuttle with all of these thermal blankets, and when I think about the fact that there is 12 stitches per inch, and there are thousands of blankets on the outside of the Space Shuttle, it's a mind-bending amount of work. I wonder, did you ever calculate how much thread you went through to
No, but we have 2.5 million shuttle parts, and they're all ID'd in 5 different ways. No, I had a thing that I did. Since I was so honored to be a part of the program, I used to keep a log book. So I would write down the part number, did a little diagram where it was going to go, what orbiter it was going to go to, and everybody would make fun of me saying, "Oh, Jean's got her book out again." But it came in handy as the program was winding down, and we had a lot of people coming in to interview us in our building at the thermal protection facility. One of the reporters asked us, "Okay, tell us what was the last flag?" The American flag is sewn into the payload bay. What orbiter got the last flag? And nobody knew. So I flipped up my little logbook and I said, I know the date. It's Discovery. And it was 2 of my friends, Jackie and Debbie, were the ones who sewed the blanket. So it came in handy. I got made fun of, but I still have that this day.
Larry Beckham is asking, did you ever work on the International Space Station modules?
No, I didn't. But in some of the earlier shuttle programs, some of those blankets and stuff that were made, I'm sure were probably, in fact, I know we made some of the modules here at Kennedy, but that was a little bit before me. Right. Good question, though.
Yeah. Well, we're running at the end of our time. Absolutely fascinating. Where can people go if they want to find out more about what you've
Oh gosh, anything
on?
To do with the Space Shuttle, just look up thermal protection system. That talks about the tiles, talks about the blankets, thermal protection for basically any vehicle that we have. I'm on Facebook if anybody wants to talk with me. I have my email. And I don't know if I can say that, but I can. A lot of people will contact me, especially on Facebook, so they can start finding me there. And I honestly answer anybody's questions. It's probably one of the most asked things is how we kept her protected.
Oh, that's amazing. Well, absolutely fascinating. Thank you so much for taking the time to chat with me today. Totally worth the troubleshooting gong show that we went through to get you here today. So again, thank you so much, and take care. Thank you.
Take care. Bye-bye. Bye.
All right, we're going to move on to the space stories this week. Let's start with Morgan Renberg. You need to be brought back up to speed here. Morgan.
Yeah, so we talked a little bit last week, a couple weeks ago, about NASA's plan to go to the moon and sort of where the money was going to come for to make that possible. And we still don't have a lot of answers to how that is going to play out, but that hasn't stopped NASA from writing the first checks to get the first pieces of the program in action. And, fortunately, the first bits of the program are science oriented. And so we're starting off in a good direction. But they signed 3 contracts with 3 small U.S. companies to put landers on the surface of the moon in the next couple of years, carrying small science payloads. And they haven't specified exactly what each of those payloads will be, but they're designed around the idea of testing out surface conditions in preparation for a landing. So one example they gave was measuring the amount of dust that was being kicked up as this lander was touching down, as a gauge for the kind of conditions, visibility that astronauts would face when touching down on a future lunar landing. And as NASA contracts go, these guys are baby. None of them, I think, are more than $100 million, and they're all for launch and landing in the next couple of years. And so that sort of illustrates a new approach to doing these things. When we went to the moon the last time, everything was billion-dollar contracts with defense contractors and big projects. And honestly, I hadn't heard of any of these 3 companies that they signed agreements with. At least 2 and maybe 3 of them are going to be launching on Falcon 9s. So everything here is low budget, low cost, and NASA described them as, quote, shots on goal. And if you're like a soccer fan, that sort of indicates good attempts, but not necessarily successful attempts. And so it suggests that NASA is willing to throw a little money around here to get something going without the expectation that everything works perfectly. And that's sort of what we've seen the last decade from commercial space, especially SpaceX. And so it's refreshing to see NASA go in the direction of trying out a bunch of ideas early on before settling on that one that they're going to load up with a lot of money.
So, it's interesting. They came really fast and furious making these various announcements. We got the Artemis project, and then within a couple of weeks, we saw a bunch of announcements about all of the international partners, and then we learned about all of these lunar landers that are going to be sending science to the surface of the moon when there haven't been any. And we actually, I think, complained about them canceling a lunar rover about a year ago as part of the acts that the White House administration was taking to NASA's science program, and now it looks like there's going to be a bunch more. Who's going to pay for all this?
Yeah, that's a good question. And I should add that these are going to happen fast. The earliest could land next year on the moon, and all 3 are slanted to land by the middle of the year 2021. So these are things that are basically shovel ready as aerospace projects go. But who's going to pay for them? So these little payments are not a big deal, but where the money is going to come from to fund the whole Artemis project is totally up in the air. And NASA kind of talked in both directions a little bit this week when Deputy Administrator Bill Gerstmeyer sort of hinted that NASA might have some hard choices to make, and implied that they may have to borrow or take money from other parts of NASA's mission to accomplish what they needed. And that kind of went in opposition to what Administrator Bridenstine said all along, which is that this wouldn't harm science or other aspects of aerospace, but would come primarily from human exploration and from new money. Now, that new money, which could be billions to even tens of billions of dollars, isn't falling from the sky. And so these first baby steps are good, but it's going to be time soon for NASA to be specific about what they need every year and to find out whether Congress will grant them that. Because it's not like they can just borrow at will from the various budgets. Congress says thou shalt spend $1.5 billion on this and $2.1 billion on that. Otherwise, all sorts of things that NASA wanted to do would be doable just by taking away from the money stuff that administration doesn't really want to do.
Looking at the budgets, right? We're looking at, say, Orbit Beyond got $97 million to send its lander to the moon, and it's going to launch on a Falcon 9. Another 79.5 going to Astrobiotic to fly 14 payloads to the moon. I mean, those are bargain basement prices for lunar landers. And I'm sure part of it is the fact that you can get a Falcon 9 launch for, say, $60 million. So,
yeah, I mean, this is sort of Bereshit style approach to landing on the moon. Probably every NASA center has hundreds of these little ideas.
Yes.
Let's put this one little box that might be matchbox sized or wallet sized or purse sized on a thing. And you can load up one cheap lander with, 15 of these little ideas, and you give your internal teams, you could build this for $1 million or something, and you load up those $15 million of payloads on this spacecraft that's going to cost $100 million, and maybe 10 of them work, and maybe 2 of the 3 spacecraft work, but you've tried out a lot of little ideas along the way that maybe you wanted to try out for a while, and that's really how these things should happen. Is it's always hard to get the money to do these little pilot projects. It's always, okay, we're going to land a orbiter around Europa or something. And you do that, but you've already sort of decided on how you're going to do it before you've done all the little pieces. It's encouraging to see the idea of trying a lot of things. And it's nice to see for once that there's an opportunity to do that before making the big commitment.
Yeah.
So if money is going to eventually come out of other pools of NASA money, if it happens, one of the things that's super concerning is all the missions that have sort of gone back and forth a lot over the past couple budgets of the administration wants to cut this, but Congress says no, and then they try again, and then Congress says no again. Things like W First and a bunch of the Earth observing missions and climate change observing missions. Is that sort of something that could happen?
I think that would require Congress sort of allowing that to happen, which, as you sort of just described, seems pretty unlikely. I mean, frankly, the place that has the most money and is the most connected to this idea is the Human Spaceflight Directorate. And so you could imagine stealing money from ISS operations to pay for this. And honestly, that would sort of be the most sensible thing to do, because if the plan is to go to the moon and establish a moon base and a deep space gateway and all of that, that's duplicating a lot of the requirements of the space station. And if that's truly where NASA and the administration want to go, then it would make sense to wind down our commitment to the space station in time with winding up our commitment to a new space station or a new space outpost. Whether that's likely to happen is a different question, but that would, to my mind, that would be the most logical and probably easiest for NASA to accomplish. The space station probably has fewer backers than many other parts of NASA does, and especially if you're just transferring that off to a new, shinier bit of human exploration.
It almost feels like we're getting, and I hate to use the term, the disruption, that on the one hand, you've got the established method, the Space Launch System, the Orion capsule, and the way this was going to go and had been laid out and began with the Constellation program and has been adapted. And here we are, 20 years later or 15 years later down this pathway, and it's cost a lot of money, and it's sort of the same sort of journey that the Space Shuttle went on. And then on the flip side, you've got just this explosion of all of these different new space companies that are actually demonstrating reusable rockets and lower cost ways to do things. And this is all sort of, and now people are having to make some decisions. Are you going to continue to fund the old method of doing it with the big budgets and cost plus accounting? At the same time, SLS is over budget and it's years late, and James Webb went through something similar. and at the same time you can buy a flight on a Falcon Heavy for $90 million. And it's
that's the other direction this could go. That's a great point. Is the other way to sort of scoop up billions of dollars like this year out of the NASA budget would be to cancel SLS, to cancel Orion, and to turn that money around and give it to Blue Origin or SpaceX to buy Falcon Heavy launches or new Glenn launches, to fund the rapid expansion of the Boeing Starliner or the SpaceX Crew Dragon. But that's an approach that has like no political possibility.
Right. It is disastrous politically.
That's the trouble.
Yeah. That lays off however many tens of thousands of people are working on these programs, all of this lobbying effort, all of these voters, construction spread across huge parts of the United States and almost every part of the U.S., every state. It's politically disastrous, and yet at a certain point it's inevitable. At a certain point it's ridiculous to overpay for what can be purchased much more cheaply via SpaceX or Blue Origin or any of these companies.
There's a guy who's pretty well known in the sort of space policy world who basically goes around to meetings like planetary science conferences or astronomy conferences and trolls scientists about the purpose of NASA, and basically justifies NASA's existence primarily and principally as a jobs program. And you don't disrupt jobs programs. If the point is to employ people in high-paying industries in politically sensitive locations, then SLS and Orion and the Space Shuttle and all of that are extraordinary successes, and you don't need to mess that up. And so I think the higher decision makers are going to have to decide what is the purpose of NASA. Is it to keep a high-paying, technically competent U.S. job force, which is not an unreasonable thing to want, or is it to go and do things regardless of whether you use international partners or lower-paid commercial partners? And it's one or the other, and one of those gets you to the moon or gets you a chance to go to the moon in the next 5 or 6 years. And the other gets you, one launch of Orion in the last decade.
Well, I suspect this is not the last time we're going to be having this conversation, and there will be a moment where it finally gets, when it gets ugly. Like, it's going to get ugly, I think, at some point. Pamela just joined us. Hello, Pamela.
Hello, Weekly Space Hangout crew and hosting suite. It's so good to see you, Brian, after so long. And of course, Kimberly and Morgan and Fraser, who I will be seeing for the rest of the evening. Hello.
Right. We're going to be recording an episode of Astronomy Cast right after we do the Weekly Space Hangout. So I don't know if this was your method of shamelessly self-promoting the Astronomy Cast episode that we're going to be doing shortly.
No, it was because I completely forgot. I had promised to come on and promote Bennu mappers, and then I got bronchitis, and then I promised again and completely forgot again to come on this week.
All right. Well, I want to chat with Kimberly first because she's got some really important news to tell us, and then and also Brian Coberline, and then we will take some time to shamelessly promote Bennu mappers, which will be great. Kimberly, what do you got?
Which news is super important?
Do you want me to choose which one I want to hear more about? I choose the update on James Webb.
James Webb, our favorite, overpriced, late, very, very, very late, and slightly depressing telescope. Actually had a good week this week. It's been a good update with James Webb. The spacecraft half of the James Webb Space Telescope has officially emerged from the vacuum testing chamber at Northrop Grumman, and it passed all of its vacuum tests. Yay! It works in vacuum.
You can handle space.
And under extreme temperature conditions, which is awesome. If you remember, this is the half of the spacecraft that had a lot of technical difficulties last year that underwent a big internal review, all sorts of weird complications, and technicians and the company not performing to the level that they needed to. It's a large portion of why the telescope has been delayed for so long and has gone significantly over budget. But it has officially passed this very critical milestone of vacuum testing, something which the telescope portion of James Webb underwent, I think, about 2 years ago. It passed those tests before it was shipped out to Northrop Grumman. Now, both of them, we know, can operate in the vacuum of space and under the extreme temperatures in the vacuum of space that they will need to perform. And now, essentially, all that's left is to put two things together, make sure it all folds and unfolds the way it's supposed to, and then launch? Question mark.
So
add
still
some more oil. Never too much
Add
oil.
some more oil.
So nobody said they need to push it back after March 2021.
No,
That is still our date.
There were no announcements of additional delays. There were no announcements of additional costs. This was, all in all, a very positive update of it has met this critical milestone on the new timeline under the new budget. It passed, and now we're ready to move on to the next stage.
You hear that,
How does it
everyone?
Yay!
How
Good
does it take
news. You're
3
welcome.
years to bolt it to the rocket.
Yeah, I don't know. Don't ask me that part. But I mean, attaching the two halves of this giant telescope together is a very important part. And then a good portion of the remaining tests are actually to make sure that it can unfold properly. Because again, this is a completely unprecedented telescope design, especially the tennis court size sun shields that have to very carefully fold to get into the rocket and then unfold very gracefully in space without anything falling apart. They're going to do very extensive tests on all of that and ensure that all the different components of the telescope and all of the instruments still function as needed after the deployment. Because once it's out there, we can't do anything to fix that. So
Well,
better get on
here's
that
hoping.
testing.
Then that's it. It's all going to be good news from here on out, and then it's going to launch, and
Now,
everything's
what are
going to
you
be
doing?
fine,
What are
and
you
then we'll get
doing
some
fixing
science.
it? What are you doing to me?
All right, Brian Coberline,
Yes.
give us some news.
So cold gas around the supermassive black hole in our galaxy. This is part of an ongoing process. We're seeing more and more near a black hole. So you remember we've seen the shadow of an event horizon that took a telescope array combine the size of the Earth. This is actually out of ALMA looking at, I would say, cool gas near the black hole in our galaxy. And cool is a relative term. It's about 10,000 Kelvin. And the reason they call it cool is because we've already seen hot gas around this black hole. So the hot gas is around 10 million degrees. And the thing about the hot gas is because it's so hot, it's so energetic, you can't see any rotation of it. It's just this kind of halo way out around the black hole. This gas is more of the accretion disk gas. So we've seen accretion disks in very active black holes where it's rapidly consuming a lot of material and you can see scatter off of that. But our black hole in our galaxy is not very active. It's really dormant. And so it's very difficult to see this gas around the black hole. What's nice about it is that because we can see this cold gas, it's close enough. It's about a hundredth of a light year. No, sorry, it's a hundredth of a light year, I think. But it's close enough that you can actually see the rotation.
Wow.
And so the light is being Doppler shifted, and we can then measure that rotation to see how it's affected by the black hole. And because it's close enough, we can start studying how material accretes into a black hole, which is one of the things that we know happens, but we haven't observed directly. We've seen the effects of it.
So do we know what the source is, where this gas is coming from, and why it's at this lower temperature? That's merely 5,000 degrees hotter than the surface of the sun?
Yeah, I mean, it's diffuse hydrogen gas. So it's the most abundant element. It is, lots of active stars are in the area. There's nebula. There's a lot of just material there. and it gets captured by the gravitational pull of the black hole and forms this kind of disk around there. So it's all of the stuff that's just there.
And would we expect that this is a similar feature that we would find around any supermassive black hole? Do you think we might see something around like more stellar mass black holes? And if so, is this a technique that we could try to find them?
It's certainly a technique that you could use to try and observe around stellar mass black holes. You're looking at the same type of scale. The big thing about ALMA is that ALMA can look at really short wavelengths for radio, what they call millimeter and sub-millimeter. And that's typically wavelengths that like water absorbs and the atmosphere absorbs, so it's really hard to see. But those are the wavelengths that cooled gas emits from. So being able to see high resolution images of this kind of cool, warm gas is now possible. And this is actually part of the Event Horizon Telescope thing. They were looking at our black hole, and because we're actually in the Milky Way, it's hard to see, and so that's why they did M87.
Yeah, another technique to be able to explore the area around the black hole to give you more information about what's actually going on in the event, around the event horizon, and just the environment around the black hole is absolutely fascinating.
Exactly. Well, certainly around dormant black holes, because this is what's powerful about this is that it's not an active black hole, and so it's relatively cold, it's relatively diffuse, it's not giving off a ton of light compared to what we think about with these things. So certainly, if you have a stellar mass black hole that's dormant, seeing the material around that, we're reaching that ability to do that.
Very cool. All right, Pamela, tell us about this interesting project that you're working on.
I am inviting all of you out there, to join me at bennu.cosmoquest.org to map out the most annoyingly rocky asteroid we have gotten high resolution images of so far. When we started writing software to allow the OSIRIS-REx team to map out this asteroid so that they can figure out where are the best potential sites to drop down their spacecraft and grab a sample of soil, we are using Itokawa as training data. In fact, the tutorial that we have at bennu.cosmoquest.org uses Itokawa data. And when you look at it, you're going to notice there's some like nice, crisp craters, there's a few boulders, and there's like 100 rocks per image. Well, the reality of Bennu is it is a rubble pile. It is the asteroid equivalent of if a giant interplanetary dump truck was flying through the solar system, hit a giant pothole, and lost its load. And that load became an asteroid. It is rocks, on boulders, on top of more boulders. And we have to somehow find a place where there's enough soil exposed and few enough giant boulders that the OSIRIS-REx spacecraft can safely dive down to the surface. And we have 4,500 images, or we will by the time we're done ingesting all of it, that each need to be viewed by 15 different people, because the assumption is we're all going to make completely different mistakes. So if a bunch of people look at the same image, we're going to make different mistakes, and the correct answers are all going to add up. So please help.
Well, there is a deadline, right?
Yes.
The spacecraft's got a job to do, and so you've got to help figure out where this thing can land so that it can bring its asteroid sample back to Earth. Like, we
have until July 10th.
Right. So we have like 35 days of mapping out the surface of Bennu to then give that data to the astronomer, or to get to the mission scientists, so they can then choose a landing spot. And I'm looking at the website right now, and there are 1,081 images completed, 2,087 remaining to go. And as you said, each one has
more images coming.
There's more coming. Yeah, Bennu, OSIRIS-REx is continuing to map and send pictures home. So, And
I
like,
think this is just the coolest thing, because most of the time when you get to do citizen science, it's on data that's already been collected. I mean, the mission could have been over for years, and even if it's not, what you're doing is helpful to the progress of science, but it's not necessarily guiding the mission.
Yeah, this is mission critical.
Well, yeah, this is the one thing that Bennu is supposed to do, and without this map, it's not going to be able to do it well or do it right. And so there's hardly a more important job to do. And it's so amazing that all of us get a chance to help with that, and to have this time pressure to do it really tells you just to sort of jump in. And that's awesome.
yeah.
And the emails I'm most looking forward to writing are the emails that are going to go to the people that mapped out those regions that are getting the follow-up observations. And then eventually I'm going to get to write that email of this place that you mapped out. That's where we're picking up the soil sample.
And also, I mean, not just the finding the location. There's also going to be weird stuff.
Oh yeah,
Right?
we've already identified a whole bunch of weird stuff, and there is, yeah, I can't say yet.
Oh, good. Yeah. But there's also an entirely, there's an opportunity to be able to identify a thing that's weird. You might be able to find evidence of an alien civilization there on the surface
More
of Bennu.
likely, you're just going to see really shiny things.
Okay.
So the one thing that I can say
The
that we've
shiny rock?
identified is Bennu is covered in super shiny rocks, and they're weird, and that's all I can say.
Right.
You hit it here first. It's diamonds all the way down.
Comes all the
No.
way down. Money.
But
precious-
that's not the only strange thing that our folks have identified. We have two different kinds of strange things that have been identified, and I'm simply super pleased. And I love the community, and I've been spot checking the data, but like doing a query on the database to find an image that has been completely mapped out, and then just randomly looking at it. And every image that I've looked at so far, the data has been good. I'll occasionally see like one person who did something strange and I can't explain, or one person that was just a little overzealous on marking dust instead of just rocks. But the data is good, and I can't stress that enough. You guys are rocking out the rocks.
That's awesome. Thanks, Pamela. And we will actually, we've run out of time. I apologize to everybody. I had a story queued up, and the short answer is that Curiosity found a whole bunch of clay on the surface of Mars, and it's super cool. And we're not going to get a chance to talk about it. I'm sorry, but clay, evidence of regions that were wet on the surface of Mars for long periods of time. They found some of the best samples of this so far. So more and more evidence that there was water once on the surface of Mars for long periods of time. And that's all you get. We've got an article on Universe Today if you want to learn more. All right. And this is going to be strange. But, okay, Pamela, you are on my screen right now. Can you let people know what we're about to do with Astronomy Cast, just so if people want to stick around or schedule the rest of their evening?
So if I still have the times correctly, 30 minutes from now, we are going live with Astronomy Cast. We are going to be recording a episode on the indigenous astronomy of the locals of Southern Africa. This is the San people, the Swanee people. Then next week, we're going to be highlighting the modern astronomy that is going on with some of the most high-tech telescopes in the world. So join us for the first half of one more two-part series, 30 minutes from now on the Astronomy Cast YouTube channel.
Excellent. Brian Coberline, how is your television show going? Anything else that you'd like to promote before we wrap up today?
So the pitch video is now completely done. So we are now in full pitch mode for a series. Wish us luck and tell all your friends. Other than that, you can find me on my website, which is briancoberline.com. I sometimes write stuff, and that's where it is right now.
Morgan Remberg, now that you're getting back to work? Anything interesting that's happened?
Yes, on Saturday, I opened my brand new exhibit called Launchpad, all about the Apollo missions and where we're going in the future. And I encouraged people to come and check it out. And I had a lovely conversation on Saturday with a Weekly Space Hangout fan who came into the exhibit. We walked around and talked about some of the stuff that was there. And that person could be you if you drop in and check it out. So we're going to be open all summer and heading into the fall. So come on by and check that out at the Fort Worth Museum of Science and History.
Go to the Fort Worth Museum of Science and History, say this is an amazing Apollo moon exhibit. Who organized this? And they'll find you in your office wherever you are. Tell them you're a fan of the Weekly Space Hangout.
It'll be a lot of fun. I think you could make it happen.
All right. Kimberly, what are you working on?
Oh, so all of my stuff that I'm working on is always on eos.org. And this week I spent a good chunk of time delving into the issue of space junk and space debris and how terrible it is in low Earth orbit and in geosynchronous orbit. It's pretty bad, and it's getting worse.
Yeah.
But you could read all about that on eos.org.
Fantastic. All right. I can't think of anything interesting that I've worked on. I put together a new video this week about an experiment that was done on the International Space Station called Expose R2, where they put a bunch of tough life forms out into space for 2 years and then brought them back, and they were like, meh, back to life. So pretty fascinating stuff. And this is part of a 2-part series. Next week, I'm going to be talking about planetary protection. So if you haven't already seen this video, that came out this week. And apart from that, that's it. I'm going to put everyone on the gallery view so we can see us all. Here we all are. So a huge thank you to everyone of the Weekly Space Hangout crew, of course, all of the people watching us today, our special guest, Jean Wright. That was wonderful. And again, apologies for all the technical support, but it all happened, all came together, which was great. And thanks to my co-hosts. We will see all of you, I guess some of you in 30 minutes, and the rest of you we will see next week for the penultimate episode of the Weekly Space Hangout before we go on to our summer hiatus. Thanks, everybody.